Hello friends, let us learn a bit more about this old Soviet programmable calculator. Especially let us learn about data registers and branching. We will use conditional branching to create loops in our program. We will try to calculate the sum of our arithmetic sequence. You know, it is told that Gauss, mathematician, when he was a child, he was asked by a teacher to sum numbers from 1 to 100, and he did it in a minute or so by applying the proper formula. But we will calculate this by iterations. We will iterate from the latest number down to 0. Let us see how this could be done. We will switch to programming mode by pressing prefix P and this PRG button. We start from the beginning, and let us assume that initially the maximum number of the sequence, for example sequence 1, 2, 3, 4, 5 and maximum number 5, is placed in the register X, and we want to loop it down to 0 and sum up all the numbers. Well, let us at first place this value into register 2. To put the value from X to register, we press the prefix button P and the number of the register P2. We will recall them later back to X register by pressing different prefix key F, probably fetch, and also the number of register. Well, now the value is in register 2, and let us clear the register X so it contains no 0, and put this 0 into register 3. Okay, these are all necessary preparations, and we can start our loop. In the loop, let us fetch the value from register 2, F2, then copy it to Y register, fetch the value from register 3, the current total, and sum them with plus button. The result on each step will be put again into register 3, P3. Okay, so far so good. Now let us decrement the current counter, the current value. We recall it from the register 2, F2, copy it to Y register, put value 1 into X register, and call subtraction. So the value in X is decremented by 1. Now we simply put it back to register 2, and also we compare it with 0. Here is X equals 0 command, which is called with also prefix because it is written above the key. And now we need to provide the address to which we will jump if the condition do not hold. I mean, if X is not equal to 0. We want to jump back to the fourth step of our program, so in this early model of calculators we want to press the key which gives the code 04. It is the key 0. Well, if the condition was true, if the counter was 0 already, this command will be skipped, and we want for the end only to recall the total from the register 3 and stop the program. Well, so far so good. Let us switch to automatic mode and test it, for example with value 5, or let it be 5. Well, we press VO to reset the program counter, press start stop, and after some flickering on the display we are going to see the result. You see the calculator is not extremely fast. Yes, it tells us it is 15. Let us try with different value, for example with 10. Yes. Reset the program counter again, start stop, again flickering. You may guess that to sum the values up to 100 as the Gauss did, it may take more time than it take from Gauss, because he knew the proper formula. So programmer should know something about formulas. Well, yes, it is 55. So far all is good. There is a special feature. We can debug programs step by step. When I reset the program counter, I can press this PP button to perform single step. For example, I enter 3 into register X and press step. Now it was copied to the register 2. Another step, the register X was cleared. Another step, the 0 was copied to the register 3, and further the value from register 2 was recalled, and so on and so on. So there were small abilities to debug the programs, and if we switch to programming mode we see where the program currently is. Well, so is how this worked, how all these 60 program steps could be filled with commands, and some basic programs could be written. I hope later I will show you how to make a simple game with this calculator, but for now I hope it's enough. So thank you for being with us. Thank you very much.